Before a tsunami begins, the ocean appears peaceful, a vast reservoir of hidden energy. Beneath the waves lies a dynamic world, pressure, density, and motion working together.
The ocean isn't uniform. It's layered by temperature and salinity, guiding how energy moves.
Here, at depths exceeding 2 miles, the seafloor stores the tension that one day may release as a wave.
The shape of the ocean floor defines how energy travels. Wide shelves, steep slopes, deep trenches. Pressure grows rapidly with depth, over 1,000 times greater than at the surface. From orbit, satellites detect subtle changes in sea level, key to understanding energy movement. Currents carry heat and energy thousands of miles, shaping global patterns. Far below, tectonic plates meet, a silent frontier of immense pressure.
Everything seems motionless, yet this stillness is filled with potential energy.
Deep currents act like invisible rivers, moving energy and heat silently across the globe.
Even the smallest organisms are moved by ocean motion, responding to invisible waves and currents.
Energy constantly moves through the ocean, even without storms or quakes.
Earth's crust here constantly moves, centimeters per year, shaping the seafloor silently. The Pacific is surrounded by tectonic boundaries, where most tsunami energy is born.
At the edge of continents, trenches form the deepest parts of our planet. Pressure builds continuously, yet remains balanced, held in equilibrium by opposing forces. Energy flows from the depths to the surface, unseen, yet constant. Every movement below eventually affects the sea above, connecting the planet in motion. Within this peace, energy waits, ready to move. Beneath the calm ocean, the Earth's plates are constantly in motion, locked together, building tension. This boundary, known as a subduction zone, is where tsunamis begin, but not from the surface.
Over decades, pressure builds silently, stored in rocks until the strength of friction gives way.
Friction locks the plates together. When that friction breaks, stored energy is released as seismic waves. Even at microscopic levels, rock minerals strain and deform under enormous pressure. Tectonic plates move slowly, but over centuries, that slow motion stores immense power.
Energy accumulates in localized zones, bastrones, invisible yet measurable. Modern sonar reveals the fine structure of the ocean floor, mapping potential stress zones. A global network of sensors tracks every vibration, the early warning foundation of tsunami science. Sometimes, the plates remain locked for centuries. The longer the lock, the greater the potential energy. Elastic energy bends the crust, storing potential motion within solid rock. Above this tension lies a calm sea, unaware of the energy waiting below. Here, one plate slides beneath another, generating shear stress deep within the crust.
When released, this energy travels outward in all directions known, compressing and expanding the medium. Earth's outer shell is in constant motion, a delicate balance between buildup and release.
Friction between plates generates heat, another indicator of active energy zones. Stillness returns Bollock. Energy remains trapped below, invisible but immense. By monitoring small vibrations, scientists detect how stress changes over time.
This invisible energy field holds the secret behind every tsunami, unseen but measurable. Soon, the energy beneath will begin its journey, traveling silently through the ocean.
A sudden release of energy sends pressure through the water column. These are not surface waves, but deep water pulses moving through the entire ocean body. Each molecule moves only slightly, yet the wave energy travels thousands of miles. Even as massive energy passes below, the surface appears unchanged.
The wave expands outward in all directions, losing little energy across open ocean.
At jet-like speeds, tsunami energy can cross entire oceans within hours. The wave moves as alternating compression and rarefaction zones. Each particle moves in place. Energy, not water, travels forward. Within 10 hours, the wave reaches thousands of kilometers from its source.
As energy meets rising terrain, the wave begins to change shape.
When water depth decreases, the wave slows and grows taller, a process called shoaling. The continental shelf acts as a natural amplifier for approaching energy. As it rises, kinetic energy transforms into potential tilt, lifting the sea surface.
At first, the surface change is almost invisible to the eye.
Most tsunami energy stays below the surface, carried as long waves of low amplitude. Energy from one fault can circle the entire planet, echoing across ocean basins.
Across open water, the tsunami moves faster than a jet plane, yet passes unnoticed.
Deep ocean buoys detect slight pressure changes known, the first sign of energy in motion. Within seconds, data travels via satellite to global monitoring systems. As the energy nears land, it begins to transform, rising from the depths to the surface. As the ocean shallows, deep water energy begins to slow down.
When depth decreases, the wave's speed drops a tad, but its height begins to rise.
This process, called shoaling, transforms deep pressure into visible surface motion.
A gentle rise begins to form across hundreds of miles.
As depth decreases to only a few hundred feet, the wave energy concentrates upward.
The same energy now occupies less depth. It becomes denser, increasing wave height.
Near the coast, the deep water pulse becomes a visible long wave.
Wave energy compresses horizontally, forcing the sea surface upward.
The seabed slows the lower part of the wave, tilting and lifting it upward.
From above, we can trace how one pulse of energy connects distant shores.
These subtle movements reveal the immense but gentle power traveling beneath. Scientists use real-time modeling to understand how energy evolves across the ocean.
A tsunami's wavelength can be thousands of times longer than a regular wave.
The ocean restores balance as energy disperses into its vast expanse.
Even after hours,
faint energy continues to ripple through the ocean basins.
From every event, we learn more about the forces shaping our planet.
From the ocean floor to the coast, tsunami energy follows predictable physics, a story of motion, not chaos. Today, early warning systems use this science to save lives worldwide.
Understanding the science behind tsunamis helps us respect, not fear, the ocean's power.
This simulation was created for educational purposes only, powered by science and AI.